Bismillahirrahmanirrahim. Uh, in the previous lecture, we covered chapter 6 of your book, and today we are going to start chapter 7, and that is continuous probability distribution. So, initially, when we were talking about discrete probability distribution, the idea was that random variable which can assume only clearly separated values are included in discrete probability distribution. And in case of continuous, you can define it as a continuous distribution usually results from measuring something. And normally, in case of discrete probability distribution, we normally count. So initially, we studied in chapter 6, if you recall your memory, discrete probability distribution, and you can define it as it is based on random variables, random variables that can assume only clearly separated values, that can assume only clearly separated values. Okay, better would be if I write it with this. Okay. So try to understand, first of all, what we have already discussed regarding discrete probability distribution. It is based on random variables that can assume only clearly separated values. Let us say number of students in your class, number of chairs in your university, number of fans in Islamabad. So those could be counted. Okay, you can't say that there are 3.5 students in your class. There are 3 students or 4 students. So a clear cut difference is there, a gap is there. So you can say clearly separated values are there. So that is the discrete distribution. So a discrete distribution is based on random variables that can assume only clearly separated values. And in this, under this head, we studied three distributions. First was binomial, then there was hypergeometric, and then we studied Poisson. So all these three belongs to discrete probability distribution. And the other that we are going to start now, the probability distribution is called continuous probability distribution. So what is that? Let me write down. Continuous probability distribution. In this case, basically, we are able to measure the variable. Let us say the length of cloth, okay, or the length from one corner of your room to the other corner, okay, similarly width. So you can measure it. So you can say that 3.2 feet, 3.23 feet, 3.233 feet, like this. So you may add several values in any value. If you are going to consider the units, then if you are going to consider, for example, kilometers, then you can also consider meters, millimeters, centimeters, and so on. So as you will go down to the smaller unit, a continuity will arise. So such variables are continuous that are measurable. So under this head, we have again uh, three types of distributions. One is uniform distribution. One is called uniform probability distribution. The other is called normal probability distribution. And then there are so many other continuous probability distributions, but in your book, exponential probability distribution is there. So we shall try to cover all these three in the upcoming classes. But today we are interested in learning the uniform probability distribution. So let us talk about uniform probability distribution. What is this? So if you have a particular starting point and similarly a particular end point, then you can use the formula that is given by uniform probability distribution to find out different probabilities. Let us say we have this example. Southwest Arizona State University provides bus service to students while they are on campus. A bus arrives at the North Main Street and College Drive stop every 30 minutes. So, I mean, the situation is this, that bus comes at some stop or some station at a particular time. For example, it starts from 6 a.m. and the service ends at 11 p.m. So the situation is this, that during 30 minutes, every 30 minutes, a bus comes and goes. So, I mean, there is a continuity. For example, if you are going to start from 0 minutes, so from 0 minutes up to 30 minutes, the 0 minute, you can say, is the start point, and 30 minutes, exactly when 30 minutes end, the interval ends. Okay. So a start point and an end point is there. So this is the property of this uniform probability distribution. I mean, starting point and the ending points, these 2 points are there. Students arrive at the bus stop at random times. So, uh, a student may come after 2 minutes, after 2 minutes and 30 seconds, or he may arrive at the bus stop just 1 second before the bus departs. So there is a continuity in arrivals. Okay, so students are coming to the bus stop, and definitely there is a continuity for their arrival. Any student may arrive during these 30 minutes at any time. Okay. So if such continuity is there, then we will use the uniform probability distribution. So two things are there: continuity is there, and a start point and an end point is there. Okay, so then there are different questions. Draw a graph of this distribution. So normally graph for such distribution is a rectangular shape graph. Uh, we will discuss this in a few minutes. Show that the area of this uniform distribution is 1. We will show inshallah. How long will a student typically have to wait for a bus? In other words, uh, in other words, what is the mean average time and what is the standard deviation of the waiting times? Okay, so mean and standard deviation. So a typical student, in you, if such requirement is there, typical student or an average student arrives, how long will he take to arrive, or how long a typical student would have to wait for a bus? If such situation is there, then it means that you have to find out the average or mean. So in this case, you would find out the average waiting time. Similarly, you are also required to find out the standard deviation of the waiting times. So we are interested in average and standard deviation. So we will see that which formula will we use to find out these two. What is the probability a student will wait more than 25 minutes? We will check. Once we will have the formula, then we will be able to find out this. What is the probability that a student will wait between 10 and 20 minutes? Okay, so basically, first of all, if I explain the graph for this, you can see the graph for uniform distribution look like this. So if you see, I'm going to solve a general case in which I shall derive the formula for average and standard deviation. Okay, so if you take probabilities on this vertical axis and you take the random variable x on the horizontal axis, then let us say this is the start point. The start point may be at this point. If it is here, then it will be considered as 0. So let us say the start point is slightly to the right of the 0. So let us say this is A. This is the start point. And this is the end point. There is any general situation. Okay. Then you can show this. Sorry. Yes. So you can connect this with dotted line. Basically, I want to draw the dotted line. And here you will write down B. This is the end point. So now if it is a rectangle, so you know the area for rectangle is there if you simply multiply the length with the width. So length multiplied by width will give you the area of the rectangle. So if you see, the length in this case is B minus A. So if you subtract, so I mean, A is from basically this point, from 0 to A. This is A. From this point to this point, if you consider, this is if A or OA, and you are interested in finding out the length from this point up to this point. So what will you do? OB minus OA will give you AB, right? OB minus OA. This will give you B minus A, you can say. B minus A or OB minus OA. It's about you, how you are considering it. So if you are going to write down OB minus OA, then you will have this length. from A to B. Similarly, if you're going to consider it B minus A, so B from this point up to this point, if it is B, you are considering this as B, then B minus A. A is from this point to this point. So you will have this length. This is the base of the rectangle, and this length is equal to B minus A. So we are, for simplicity, going to consider it B minus A instead of OB minus OA. So B minus A is the length. So we know length multiply by width. This gives you the area of the rectangle, and basically that area, you can write down over here area, but basically area will be 100%. Area of rectangle. So whatever is the value for area, that value will be 100%. Okay. So if that is 100%, we can write down that as 1. Okay, as we are interested in probabilities. So 100% mean 1, or 1 mean 100%. Okay, so 100% area. 100% area is of rectangle is equal to length into width is equal to 1. So what is length? We have found B minus A. This is our length. This is our length. And what is width or height? In this case, if you are going to consider height. So what is the height? Okay. So you are interested in finding out height, and if you consider height, the vertical axis. So vertical axis is there. If you see, it is px. So if I generalize the case, I can take it as f of x. So if it is fx, then you can write it down as, we'll use the probabilities later on, but for simplicity, you can write it down as f of x. So what is f of x? Or you can also write px, no problem. But normally, as you are familiar with the functions, so I'm writing it down as f of x. So so f of x means height. So f of x is height, and b minus a is length. So this is equal to 1, 100%. So now if you write down f of x, and you are interested in finding out the value for f of x, basically, so you will multiply, or you will have to perform another, you can say you will write down another step. So equation will take this form, b minus a. So now 1 divided by b minus a is basically the height, and height will remain same in all cases. 1 divided by b minus a. I mean, if you have the value for b, the end point, and value for a, the starting point, then you will have the height of the distribution, right? Height of the distribution is 1 divided by b minus a. So you can write down over here, this point, it is 1 divided by b minus a. Right? So now, if you simply multiply b minus a with 1 divided by b minus a, so the answer will equal 1, 100% area of the rectangle. Right? So now this is very clear that how will you find out the area of the rectangle. Okay. So if you are interested to answer this question, draw a graph of this distribution. How will you draw this distribution? Simply, you will write down over here at this point, you will start from 0. Let me draw a graph for you first. Answering part A, the graph will look like this: 0 minutes up to 30 minutes. Okay, here are the probabilities, and this is the random variable x. So 0 up to 30. So draw a graph for this distribution. You know, bus comes and goes or departs every 30 minutes. So time starts from 0 minutes, ends at 30 minutes, and then again start from 0 minute. So from 6 a.m. to 11 p.m. After every 30 minutes, buses are coming and they are going from the bus stop. Okay. So in this case, A is equal to 0 and B is equal to 30. Okay, so if you are interested in solving part 2, show that the area of this uniform distribution is 1. So how will you give the answer? B minus A, that will become 30 minus 0. This is your length. And what is height? 1 divided by 30 minus 0. When you will solve it, you will have 1. So in this way, you will prove that the area of this uniform distribution is 1. Then there are questions that how long will a student typically have to wait for a bus? I mean, you have to find out average, and this is also given over here. That what is, in other words, what is the mean waiting time or average waiting time that a student will wait? Basically, an average student will wait for how many minutes? Or otherwise, in other words, the mean waiting time is required. Similarly, the standard deviation of the waiting times also required. So the formula for that is basically mu in this case is equal to A plus B divided by 2. And standard deviation is equal to B minus A square divided by 12 and square root of this. So if there is square root, then it is standard deviation, and if you are interested in finding out variance, then the square root will not be there and sigma square will be there. Okay, so now today I am interested in solving a question for you, and also I'm interested in deriving the average and the standard deviation formulae, how this is the formula for uniform distribution. Okay, so now let us try deriving the formula, and I'm going to derive mu is equal to A plus B over 2 first. Okay, so the question may be in case of uniform probability distribution, or you can say prove that in case of probability distribution, uniform probability distribution, the average mean is equal to A plus B divided by 2. Okay, so you are familiar with the integration, and if I write it as EX, what EX means? Average. This is average. Expected value of X, we also call it average. You will see EX in the course when you will study econometrics. So in econometrics, you will see EX. So we normally use EX as average of X. In other words, you can write it down as X bar. X bar is equal to E of X, expected value of X. So if you take help of integration, because normally when we are talking about the discrete probability distribution or simple average, then we simply what we do, summation X divided by N. Okay, but in this case, continuity is there. So therefore, we take help of integration, and we say that the interval starts from A and ends at B. So this integration means there is some continuity in values A to B. Okay, and you can write it down as X into f of X and then dx. So you can write it down in this way. So if you have the value for this, basically we are interested in finding out or in solving this to have this mu is equal to A plus B over 2. Okay. So, the height in all cases will remain as 1 divided by B minus A. This height will remain same for all cases. This height will remain same for all cases. Okay. So this is a constant value. Okay. So I'm going to write down this constant value instead of f of x. So from A to B, and then f of x is 1 divided by B minus A, and f of x we have written 1 over b minus a, and x is there as it is, dx. So now you can take constant out of the integral, and then you can write it down as 1 divided by b minus a to b, and x dx. Okay, so now you will solve this x dx. You know the formula. It will become 1 divided by b minus a, and x square divided by 2, and it is from a to b. So in this way you can open this x square divided by 2. If it was x square over here, if it was x square here, then it will become x cubed divided by 3. If it was x4, x5 divided by 5. So this is the formula. So as the power for x here is 1, so 1 plus 1, so it will become 2 and divided by 2. So x square divided by 2, and interval is from a to b. Fine. So now you are familiar with the situation that how you will substitute the values over here. So you can write it down as 1 divided by b minus a, and x squared divided by 2. So once you will substitute the value x square, so the interval ends at b, so you will write down here b, x square, so b square. Okay, divide by 2 minus a square divided by 2, or otherwise you can take 2 out as common. Okay, or otherwise you can also write it as in this way. If you are going, because this is constant, there will be no substitution in constant. So constant you can take out. Okay, so if you are going to take out constant, then you may write down, instead of writing this term, you can also write down 1 divided by 2 into b minus a into b square minus a square. Fine. So now b square minus a square, if you recall your memory, you will know that b square minus a square is equal to b plus a multiplied by b minus a. So let us write down that. 1 divided by 2 b minus a into b plus a and b minus a. So the value for b square minus a square is equal to b plus a multiplied by b minus a. Now you can see that denominator b minus a, numerator b minus a. So you can cancel these out, and you will remain with b plus a over 2. So you can write down a plus b over 2. So hence proved. This is the value for ex, and we also call it mu. We also call it mu. So ex, so you can write it down as ex, or it is mu. Same. Fine. So we have proved that the average in case of the formula for mean or average in case of uniform probability distribution is a plus b divided by 2. So are you with me?
Yes, sir.
So now I'm going to prove the formula for standard deviation in case of uniform probability distribution, that is a form of continuous probability distribution. So you know variance, for variance we know variance of x, if I write over here variance of x. So you are familiar with this, that variance of x is equal to x minus expected value of x and whole square. X minus ex whole square. Okay, so this will become basically now you have to solve it in few steps, and then you will have some value that you will use. So basically, if you know what is this, the dispersion from mean. What is this? This is the dispersion from mean, and that is basically the standard deviation, dispersion from mean. So when you will take square of this, it will become variance, dispersion from square of squared deviation from mean, you can say. So this is basically the average, as I've already explained, ex. So x minus mu, x minus x bar, you can also write x minus x bar. So when you will apply E on this, so it will become average of the dispersions, average of the dispersions, and that is also called variance, right? So basically now you are going to take the average of dispersions. Okay, and if you will write down over here, square, so squared dispersions, squared deviations, in other words. So now I'm going to open this, and it will become x square, okay, plus, oh, the formula is same. If you have a minus b whole square, so a square plus b square minus 2ab. So whole square minus 2x ex, 2x ex, fine. So now you have to apply the expectation on this. You have to apply the expectation on this. What will you have? When you will open it, you will have this term, e of x square plus. Now you're going to apply expectation on this term, and in this term, if you see, expectation is already there. So if you have some average value, what is the you can say average of average? Average of average is average, no problem. That is a single value. So therefore, expected value of e of x, you can write it down in only one term, ex whole square. This is the term as it is. When you will apply e on this, it will remain same. Minus 2, 2 is constant out. And when it will be applied on x, it will become expected value of x. And again, when it will be applied on ex, so that will remain same. So ex. Right? So in this way, you will write down this term. Then this will become ex square, and let me write down for you, ex whole square minus 2 into ex multiplied by ex. It means ex whole square. Okay, so now you can see that this term, this is ex square, and this is minus 2 ex square. So when you will subtract this term from this, you will have e of x square. So remember, here there is x square, and in the next term it is ex, not x square. Square is on whole term. So this is basically the formula for variance. You can also write down it as sigma square variance, or variance of x, as I have written over here. So now we are interested in solving this side, right hand side. Once we will solve this side, we will have this formula. Which value will we have? We will have this value, b minus a whole square divided by 12. So we are basically interested in obtaining our goal, And our goal is to reach at this. Sigma is equal to b minus a whole square divided by 12. So let us see how this term comes from this. Right? So I'm going to solve this because e of x, we already have the value for this. The value for e of x is a plus b divided by 2. So when you will take the square of that, you will have the this whole term, a minus a plus b divided by 2 whole square. So you will have this term. So it is you can say a ready-made term, the value for which we have. But we are interested in finding out the value for this term. Once we have the value for this term, we will substitute in this equation, and we will subtract this ex whole square from that. We will have the value. So let us say this is our equation A or B. So then we are going to find out this e of x square. Okay, so if you see, when I started and I found ex, so I started from this point, integral a from b, a to b, and x and f of x dx. So now when x was there, I wrote here x. When x square will be there, I write down x square. The remaining terms will remain same. So let us write it down. Started from a to b, x square, f of x dx. You know, I have said that the height will remain same, that is being represented by f of x. So it is 1 divided by b minus a. That will come out of the integration. And this term will go out of the integral, and then a to b, and then x square dx. You will have this. Now when you will solve this using the integration formula, so this will become x cubed divided by 3. So let me write down 1 divided by b minus a. Sorry, there is no integral sign over here. There is braces because I'm going to open it. So x cubed divided by 3, this line, a to b, this is the interval, and then you will substitute the a and b in x cubed, because this is the constant, you can take it out. So write another term over here, 3 into b minus a. 3 into b minus a, and you will remain with x cubed a to b, right? And then you will substitute the values. This will remain same, b minus a, right? And this will become b cube minus a cube. This is the way that we will substitute the values. A cube. B is the end point, A is the start point. So end point minus start point. So B cube minus A cube. Okay, so now you are familiar with this. You know, B cube minus A cube is equal to what? B cube minus A cube is equal to what? So I'm going to write it down. 1 divided by 3 into B minus A. And now you write down B cube minus A cube. So it is equal to B minus A, B minus A multiply by B square plus A square plus AB. We had proved this formula, I think, when I was explaining the idea of binomial probability distribution. So we can prove this formula from there. B minus A multiplied by B square plus A square plus AB. So when you will open this formula, you will have these two terms. This multiplied by this. So now you can see that this is the numerator, this is the denominator. So these two values will not be there, cancelled out. You will remain with B square plus A square plus AB. divided by 3. Divided by 3. So now this is the value for ex square, this term. Now I'm going to substitute this answer here in equation A. So it will take the form sigma square. Now you can write down substituting the value in equation A. We will have sigma square is equal to b square plus a square plus ab divided by 3. And we have to subtract something from this. What is that? Ex whole square. So what is the value for ex? A plus b divided by 2. So you write down over here a plus b, the value for e of x. A plus b divided by 2. So square of this is there. So now when you will open it, it will become a square plus b square plus 2ab, and this 2 will become 4. So this will equal b square plus a square plus ab divided by 3 minus a square plus b square plus 2ab divided by, 2ab, we write it down clearly, 2ab divided by 4. Understand? Is it clear up to this point? So you can at least speak yes or no so that I may know that you are with me. Otherwise, I have to open this and see
Yes, sir.
if you are there. And from here, I can see that these many students are there in my class. Yeah.
Yes, sir.
Yes, thank you very much. Thank you very much. Okay, so further, when you will solve it, you will take LCM. So 4, 3, you can take here 12. You can write down here 12. So this is 12. So 3, when you solve it, you will have 4 into b square plus a square plus ab minus 4 threes are 12, and you will have 3 into a square plus b square plus 2ab. Fine. So now open this. You will have 4b square plus 4a square plus 4ab minus 3a square, 3a square minus 3b square. And finally, when you will multiply this 3 with this 2, it will become 6. So minus 6ab, minus 6ab, and divided by 12. Now you can see this is 4b square, this is 3b square. So on subtraction, you will have plus b square. So b square, when you will solve this, and this. Then come to a, 3a square and 4a square. So you will have plus a square. And then 4ab and 6ab, so you remain with 2ab or 2ba, no problem. Divide by 12. So now you can write down a minus b whole square by 12 or b minus a whole square by 12. So I'm going to write it down as b minus a whole square divided by 12. What is this? This is my variance. And if you see, standard deviation, if you're interested in finding out standard deviation, so then you will write down that taking square root on both sides of the equation, we will have b minus a whole square divided by 12, and there is square root on this whole term. So b minus a square divided by 12, this is what we required, as I have written over here. Yes, sigma b minus a square by 12. So this is there. Okay, so now come to this question, and we had solved. So this is self-review, and basically we are solving this question that is there in your book as an example. Yes, this question. So typically, how much a student would have to wait? So answering part three, you are required to find out mean. So the formula for mean is a plus b over 2. The formula for mean is a plus b over 2. How will you write it down? Answering part 3, you will write down mu. What is a in this case? A is 0. What is b? B is 30 divided by 2. The answer is 15. Fine. The answer is 15. Clear? And then there is a question, what is the standard deviation of the waiting times? What is the standard deviation of the waiting times? So you know the formula, standard deviation. We have just found b minus a whole square divided by 12. So what is b? 30 minus a is 0 whole square divided by 12 square root. Yes, quickly solve it and give me the answer. 30 square divided by 12 square root. Yes, quickly. Yes, what is the answer? It means you don't have calculators with you. You're just enjoying the online lecture. There is no need to use your hands on calculator. So that may be problematic. You must have calculators with you. This is statistics. 30 square
66025, sir.
divided by 12 square root. Yes,
It's 8.666025, sir.
8.66. So this is the standard
25.
deviation. Then there comes a question. What is the probability a student will wait more than 25 minutes? A student will wait more than 25 minutes. Now, this is a question that you would have to answer. Probability, let me write down, probability that a student will have to wait more than 25 minutes. So you write down in this way. Fine. And for this, again, this is the probability of x. And you know, the probability of x, in this case, you are going to use the uniform probability distribution formula. So rectangle is there. So rectangle is there and area of rectangle is length into height. Length multiplied by height. So first of all, you have to find out the height and the length. So you will draw the graph. Let me draw the graph. Let us say this is the graph. 0 minutes, 30 minutes. 0 minutes and 30 minutes. And you know, 1 over b minus a. What is this? 1 minus 1 divided by b minus a. So 30. 30 minus 0. So that is 30. 30 minus 0, that means 30. 30 minus 0, 1 divided by 30. So the required probability is x greater than 25. So let us say at this point, this is 25. This is 25 minutes. So if you find out this area, if you find out this area, so again, this is a rectangle. So if you find out this area, you will be able to find out or to give this probability, that is x greater than 25. So now if you see this, in this case, the starting point has become 25. So this is now your A and this is your B. So how will you find out the length? 30 minus 25. And what is height? Height is same. Height will remain same. So you will write down it as, first of all, length. What is length? 30 minus 25. Multiply this with 1 divided by 30. So 5 divided by 30. What is the answer? 1 by 6. Clear? Clear? Fine.
Yes, sir.
Okay, so then there is a last question. What is the probability a student will wait between 10 and 20 minutes? Between 10 and 20 minutes. So for that, again, you will draw a graph. You know, there is 0, there is 30, there is 10, and here it is 20. So now you are interested in finding out this area. If you have the value for this area, it means you will have the answer for what? For this, the required probability. What is x? X is the random variable waiting time. What is required? Will wait between 10 and 20 minutes. Between 10 and 20 minutes. 20 minutes, 10 minutes. So between means the value for the random variable is, or x is, greater than 10 and less than 20. Okay. So greater than 10 minutes, less than 20 minutes. So from 19 minutes up to 59 seconds will be there in this interval. And in this interval, it will start from 10.1 seconds. So 10 minutes and 1 second will be there in this interval. Fine. So continuity is there. So answering this question, again, the rectangle is there, but now height is same, 1 by 30. Okay. So now this point will become your A and this point will become your B. So B minus A, you will have the length for this segment. Okay. And this segment will remain same, 1 by the height is same from all points. If you see it from here, it is 1 by 30. It is so same for from each point, 10, 20, 30. So height is same, 1 by 30. And you are interested in finding out this length. So 20 minus 10, B minus A, 20 minus 10. So write it down. 20 minus 10, this is your length, and height is 1 by 30. So 10 by 30. 10 by 30, sorry, 10 by 30, or you can write it as 1 by 3. 1 by 3. So this is the probability. You can write it down in decimals, up to 4 decimal points. Fine. So in this way, if I ask you that what is the probability that the waiting time is less than 10 minutes, so you will take this length into your account. So 10 minus 0 will be there. If I ask you that it is in between 30 and 10, so this will become your A and this will become your B. So 30 minus 10. So there could be several scenarios, and you can take into your account all those scenarios, no problem. You are able to do that. So now you are suggested to solve few questions from this section, that is uniform probability distribution. And definitely, inshallah, if you will do it today, there will be no problem for you solving the questions later on. Okay. So this is all from my side for today. Thank you very much for your patience. Goodbye.